In this section, we're talking about different parent graphs, and parent graphs are like the most simple of a certain type of function. So for example, we have the linear parent graph, which we normally see written as like y equals mx plus b, but the most basic of that is y equals x. So the the slope is 1, the y-intercept is 0, but that is the most basic one, y equals x. And then the most basic cubic is y equals x cubed, and then the square root. And we'll look at a couple different ones today. And we're going to practice identifying key features about each graph. So in order to figure out how to graph this, if you don't remember, or if you see a new type of function that you don't know what the graph looks like, you can use your graphing calculator, or you can make a t-chart. But you just want to find some x and y values that you can plug in and get some points that you can fill in on your graph. So I'll do some positive and negative. Oh, -1, 0, 1. And sometimes you don't need like this many points, but sometimes you do. So -4, if I plug in a -4, I get -4. So the y equals x, meaning y and x are going to be equal to each other. They're going to be the same. So these will all be the same. This is a linear, so we'll graph all those. -4, -4, -3, -3. So it's a linear, it goes right through the origin. And then we just connect them, and it keeps going that way. And it keeps going this way, except it's probably be easier to do if I just kept those dots going. There we go. So it goes that way, it goes that way. Let me keep this going on this side so I can graph across the whole graph. Straight line all the way across our graph, just like that. There's our graph. Okay, now that we have it graphed, domain. So for x and y values, what's our lowest x value? What's our highest x value? Do we skip any? And in this case, we don't. It goes left forever, right forever. So it's -infinity to positive infinity. So for our x values. And then the range is looking at the y values. So how high and low. So which of these y values we're going to use. So again, in this case, it goes down forever and up forever. And always do your lowest first. So if you have two infinities, like the -1 always goes first because low to high. X-intercept, so you look along the x-axis. Does our function cross the x-axis anywhere? And it does at 0, 0. Y-intercept, you look along the y-axis, see if it crosses the y-axis anywhere, and it does at 0, 0. Is this graph 1 to 1? So remember with 1 to 1, we're looking for, does it cross the vertical line test? Which this one does. We also need to know if it crosses the horizontal line test. If it crosses both line tests, so it can only, every horizontal and vertical line can only touch your graph once at one point on the graph. It cannot ever touch more than once. If it passes both horizontal and vertical, then it's a yes, it is a 1 to 1. So the inverse exists as well. Extrema, when we're talking about max and min values, max, min. And so in this case, since it goes up forever, down forever, there's not a lowest or a highest. So this is no max or min, so there are no extrema values. Increasing and decreasing. So remember, for increasing and decreasing, we're only looking at x values. So we go from left to right. So from left to right, make sure you go in that direction. So as I follow my graph this way, and just pretend like I'm on, let me switch colors so we can be on top of it. As I'm following my graph, just like this, am I increasing or decreasing? And the answer is increasing. You always follow it from left to right. So, and this function never decreases. So it starts increasing, and increasing, decreasing, we're only looking at x values here. It starts increasing at -infinity because it is always increasing. And then it continues increasing forever. So increases forever from -infinity to positive infinity. That means it never decreases. So decreasing, there's none, not applicable, whatever you want to write. End behavior, we just want to know what the right and left sides of the graph do. So if you just want to write like right and left and then tell me what it does, that works for me. So left end behavior goes down. So if you notice to the left, it's decreasing. So the left side is going down. And the right side, as I go off to the right, you just follow it and it's increasing. So that is going up, it is increasing. So sometimes it goes up, sometimes it goes down, sometimes it like flattens out and goes to a specific number, but in this case it's increasing and decreasing. Asymptotes, this one doesn't have any asymptotes. Even or odd, so even functions, they're symmetric on the y-axis, symmetry on the y-axis. And so if you look at the y-axis and fold your graph on top, in half on the y-axis, it would fold on top of itself. So in this case, that is not the case. So it's not even. Odd functions are when you have a rotational symmetry. So rotational symmetry, if you rotate 180 degrees around the origin. So about the origin. So if I take this graph and here, put my finger right here on the origin and spin it upside down, if you spin it 180 degrees and it lands on top of itself, then it's odd. So in this case, this is a yes, it would spin on top of itself. If you turn this graph upside down, then it would look exactly the same. So that's an odd. And then you also have, like, some of these graphs are neither. So I guess it should say even, odd, or neither, because that is an option as well. And some are both. Some are even and odd. Some graphs are. So that's what we're doing for all of these functions today. So I'm just going to do a couple of them, and then you can fill in the rest on your notes and the rest on your assignment. So looking at our x cubed function. So we're going to plug in some numbers. Again, on your calculator, you can plug in the graph like or the equation like you're going to graph it, and then just click on table, and it will give you some numbers that you can use on your graph. So -3. All right, so we need to plug those in. So this time we're going to plug them into the x value right here. So -3 cubed is -27. So that's not going to fit on our graph, but that's okay. -2 will give me -8. -1, 0, 1, 8, 27. So let's just use the ones we have that fit on this graph. So we have 0, 0, 1, 1, -1, -1, 2, 4, 6, 8, and +2, 2, 4, 6, 8. So our graph is going to curve this way, and then it's going to curve going this way. Okay. And then we list our characteristics. Domain, left and right. It is pretty steep, but it does go left forever and right forever. The range is talking about up and down. So down, it goes down forever and up forever. X-intercepts, it crosses the x-axis at 0, 0. Crosses the y-axis at 0, 0. 1 to 1, it passes the vertical and the horizontal. So this is a yes. Extrema, this is maximum and minimum, goes up forever, down forever, so we don't have any of these. Increasing, again, for increasing and decreasing, you have to follow it from left to right. You have to follow it that way. So starting on the left side and then following our graph to the right, it looks like it's increasing the whole time. So increasing from negative to positive infinity, and it is never decreasing. End behavior, what are the right and left sides doing? So the left side looks like it is going down, and the right side is going up. It's increasing. No asymptotes. Even, is it symmetric on the y-axis? That is a no. Odd, if I rotate it, does it look the same 180 degrees? And that is a yes. It is an odd. Well, I guess I don't put yes because it's not a yes or no question. It is odd. I remember you have even, odd, or neither sometimes. Okay, square root function. So if you notice when you put in your square root function, negative numbers don't give you anything or gives you an error because we can't take the square root of a negative number. So we just keep going. 5, 6, 7, 8, 9. And if you want to look at the table on your calculator, and just write down the points that you're going to be using when you graph, not necessarily all of them, that will work too. Because if I plug in a 0, I get 0, plug in a 1, I get 1, plug in a 4, I get 2. The ones in between give you decimals, which are a little bit harder to graph. So if we can figure out enough points to use that are nice to us, so if I plug in a 9, I get a 3, we can just use those points and ignore the others. So we have 0, 0, 1, 1, 4, 2, and 9, 3. And there we go. Going off that way. So domain, looking at our x values. So left, it does not go left forever. It only goes down to 0 on the left side. And it does include 0. And it goes up to positive infinity. On the range, we're going up and down using y values. So it does not go down forever either. It goes down to 0 is as far as it goes down, and then it goes up to positive infinity. X-intercepts at 0, 0, y-intercept in the same place. Is it 1 to 1? It passes the vertical and the horizontal, so this is a yes. Extrema, do we have any max or min? We do have a min this time, because this time it doesn't go below a certain number, so we have a minimum at 0, 0. That's our minimum point. Increasing, decreasing, going from left to right, it looks like it's increasing the whole time and will increase forever. So it's increasing, and this doesn't get a bracket because 0 right at the end point, it doesn't count as increasing or decreasing because it's just the end. So from 0 to infinity, it's increasing, decreasing. We don't have any intervals where it's decreasing. End behavior, so the left side doesn't go anywhere, so we're just going to say the right side is increasing. Asymptotes, we have no asymptotes. And even, if I fold it on the y-axis, it does not do anything. If I flip it upside down, it does not look the same, so this is a neither. Okay, next function. If you're trying to get absolute value on your calculator, you go to math, over to number, and then I think it's number 1. It says ABS. You get the absolute value of x. So you graph it, get all of those characteristics. I'm going to let you guys do this one. Let's do the reciprocal function together. So y equals 1 over x. So get some x and y values here. So I'm just going to do a few. And I'm going to plug those in. So what if I plug in a -3? I get -1/3, -1/2, -1. 0 makes it undefined. So the point does not actually exist there. So actually, we have an asymptote right there. And then if I plug in a 1, I get 1, 2, I get 1/2, and 1/3. Okay, so looking at your graphing calculator will give you a good idea of what this graph looks like as well. So -3, -1/3, -1/2, this. So, and then we have an asymptote here. So if that's the case, as we approach this graph is going to have to go this way, because it can't ever cross that asymptote. And then we have 1, 1, 1/2, 1/3. So it's going to do the same thing going this way. So when I connect these going this way, it's going to go up like that, but it won't ever cross. I know I kind of graphed it, so it looks like it crosses. Or touch. It doesn't ever touch it either. But then we also have a horizontal asymptote for our reciprocal function. So as we go off to the right, it goes this way. As we go off to the left, it goes this way. So we have 2 asymptotes this time. So domain, from left to right, it goes left forever, right forever, but we do have that asymptote right in the middle. So the number 0 is not a point, it's not a part of our graph. So our domain is -infinity all the way up until we get to 0, but we're going to skip 0, so put that in parentheses. And then we're going to union that with the graph on the right. So from 0 to infinity, we also include that in our domain. The range is the same since we have a horizontal asymptote as well. So we have this all the way up until we get to this number, and we have to skip 0 and then go on from there. So it goes down forever all the way up till we get to 0, and then it skips 0, and we start over and it goes all the way up to infinity. It goes up forever. X-intercepts. It does not cross the x-axis. Neither does it cross the y-axis, so neither of those. One-to-one function. If we look at a vertical line test and horizontal line test, it actually passes both. So this is a yes. It goes up and down forever, so we have no extrema. Increasing. So again, following this left to right. So if we follow left, it looks like this part is decreasing, and it looks like this part is decreasing as well. So this one is actually decreasing always. Except we have to skip 0. So it's never increasing, so we can put none or not applicable. It is decreasing from negative infinity all the way until we get to 0. 0, it's not doing anything because it doesn't exist at 0. And then it picks up decreasing again once we get to 0 all the way to infinity. So different ways of decreasing, but it is still decreasing from left to right. End behavior, the left side goes to 0. It doesn't go up or down, it's getting closer and closer and closer to 0. And the right side also goes to 0. It's getting closer and closer and closer to 0. Asymptotes, we have x equals 0, so that's our y-axis, and y equals 0, which is our x-axis. Even, it is not symmetric on the y-axis. Odd, if I flip it upside down, it is the same, so this is an odd function. And with logarithmic and exponential functions, these are tricky because this number could be a lot of different numbers and it would still be a basic logarithmic equation. So there are a lot of different parent logarithmic functions. And so we're just going to graph this one that is log base 2. So again, if you're looking for log base in your calculator, you go to math and then scroll down until you get to log base. And then that will allow you to put in whatever base you want into your calculator. And then you look at a table and go from there. Let's see what values we can find. So if you notice on this one, anything negative or even 0 does not exist. So it does not exist at 0. And then once we get into the 1 and 2 and whatever, we get some numbers. So 1 gives us a nice number, 2 gives us a nice number, 4 gives us a nice number, and I bet 8 is going to give us a nice number. Okay, so let's graph this. So 0 does not exist. So this is actually going to give us an asymptote right here. Logarithms have a vertical asymptote. 1, 0, 2, 1, 4, 2, and 8, 3. Okay, so that goes this way. But again, we have an asymptote, so as we come back this way, it's got to swing down because it's not ever going to cross that asymptote. So domain, it does not go left forever. It doesn't start till we get to 0, but it doesn't exist at 0, so parenthesis, all the way to the right forever. The range for y values, it goes down forever and up forever. So range is negative to positive infinity. X-intercept is at 1, 0. It does not cross the y-axis, so no y-intercept. 1 to 1, this is a yes. It passes the vertical and horizontal line test. Extrema, we don't have any. It doesn't have a low or a high point, a lowest or highest point. This, as I follow it left to right, is increasing the whole time. So it's increasing from 0 to infinity. We don't have any intervals where it's decreasing. End behavior, the left side doesn't go anywhere because it doesn't go left forever, but right forever does increase. It looks like it's going to flatten off, but it doesn't. It does increase forever. Asymptotes, we do have 1, so this is where x equals 0. That's the y-axis. It is not even, and if I flip it upside down, it doesn't look the same, so it's not odd. So this is neither. There we go.